some variation within the data set. So how does the data, how do the numbers vary given any type list of numbers? So measures of central tendency that we talked about last class, the mean and the median, give us numbers that describe a typical data set. Okay, when you calculate the mean or the median, we crank out a number and it says something about the data. But they do not let us know how much variation there is in the data set. Okay, it tells us something about the data, or about the numbers, but it doesn't tell us how much the data varies. So two data sets can have the same mean, but look radically different depending on how varied the numbers are within the set. So what do we mean by this new word, this variation of the numbers? So the two data sets below have equal means. So the mean of data set 1 is the same as data set 2. Do these look different? Yeah, okay. Data set 1 clearly has more numbers in it than data set 2 does, but their means are equal. But they differ in the variation within the set. Use your calculator to determine the interquartile range of each data set. And it tells you the IQR is defined as the difference between the third quartile and the first quartile. So the IQR is equal to Q3 minus Q1. In other words, when you have a dot plot, excuse me, I misspoke. When you have a box plot, it's the box, okay? So if I were to just draw some random box plot, this is Q1 and this is Q3. The IQR is the difference between Q3 minus Q1. So it's the box itself on a box plot. So let's go ahead and go to our calculators and let's toss both of these data sets in and do the calculation. So we just entered our information, our data from data set 1 into list 1 and make sure we title it X. So we don't need to construct a box plot to do Q3 and Q1. So just go right to Menu, Statistics, Stat Calculations, and we only have one variable because we only have one list right now. Right? Number of lists, just one, so we click OK. And what did we call our list 1? What did we call our list? We called it X. Right? And we can jump right down to, we don't need to change anything else in there, jump right down to the OK. So a little review, X bar, what did we say X bar stood for yesterday? The mean. Okay. Then if we scroll through our list, we find Q1 is 4.5 and Q3 is 9.5. I don't believe the list gives us the IQR, but I certainly could scroll through it. No, it doesn't. So we got to do a little subtraction. I think we can handle that. So 9.5 minus 4.5. So the IQR for data set 1, 9.5 minus 4.5 gives us 5, right? Okay. So the IQR, that box, if we were to make a box plot for data set 1, the box would be 5 integers wide, right, on the number line. So now let's go ahead and do the same thing for data set 2. We go again. So for data set 2, Q3 is 8, Q1 is 6. So the IQR for that data is 2. Yeah. So the IQR is 8 minus 6, which is 2. So if I were to make a box plot of that, would my box be bigger or smaller for data set 2? It would be smaller. Okay? It'd only be 2 integers. So what does that tell us? It tells us that there is less, this is the big understanding here, there is less variation in data set 2 than there is in data set 1. Data set 1 has a larger IQR, so therefore there's more variation within these numbers. Would you agree, just by sort of eyeballing it, just by looking at it? These go from 3 all the way up to 11, but these go from 5 to 9. So now, what was I just doing there? I went from 3 to 11. What am I getting at? What word am I getting at? 5 to 9 for data set 2. What am I talking about? The range. So the range is a very basic, form to see variation. It's very basic. And I call that the bronze level to determine variation. That's my own type, bronze. So the IQR, what do you think I consider the IQR to be? Silver. Okay, it's a little bit better in determining variation. So now we need to learn about which one's the gold. Okay, we're going to get to that one. So now this right here in the middle is going to sort of summarize probably what I just talked about. The IQR range gives a good measure of the spread of data or the variation. But the best measure of variation within the data set is the standard deviation. That's going to be the gold. Okay? That one is going to be the best. So back up here, standard deviation is going to be the gold. That's going to be your best one to determine the variation or the spread within your numbers. The actual calculation, that calculation of standard deviation is quite complex, but we're not going to get into it. We're going to let the calculator do it for us. Okay? So we rely on the calculators to crank this out. Using the same data sets above, so from data set 1 and 2, use your calculator to produce the standard deviation shown as that little guy right there. That's the symbol that we're going to look for, okay? And that is a lowercase sigma. Okay, it's a Greek letter, and it's the lowercase version of the Greek letter, and it's sigma. Okay, and it's sigma x. Okay, and that's the symbol for standard deviation. So we already have data set 2 in our calculator, right? Did you guys clear it out or no? Yeah, don't clear it, okay, because we can use it. So we have data set 2 in here, so now let's scroll through and find that sigma x. Did you scroll through your list and find it? Sigma x. And then, so what did they ask us to? To the nearest 10th? So what did we get for that one? 1.4. Yep. Okay, so that was data set 2. So the standard deviation for data set 2 is 1.4. We're going to see exactly what that means, but it, again, is telling us about the variation within the data. So we came up with, let's make a prediction. IQR was 2. IQR was 5 for data set 1. We said there was more variation in data set 2. We now just came up with the gold version of variation is 1.4. What's going to be your prediction for the standard deviation for data set 2? Is it going to be less than that or greater than that? Greater, yeah. And for the sake of time, because we already eliminated data set 1 in our calculator, it's 2.7. Okay. Great. So our prediction was right to come up with that. Okay. So what exactly is standard deviation? It tells us about the variation, but what specifically about the variation? The standard deviation of a data set tells us, on average, how far a data point is away from the mean. Just marinate on that one for a second. How far a data point is away from the mean. So we know how to calculate the mean. And a standard deviation is that distance, okay, from the mean to that data point. So meaning, the larger the standard deviation, the more spread out our numbers are going to be, and the smaller the standard deviation, the closer those numbers are going to be. Okay. It's like I'm the author of this, and I'm clearly not. The larger the standard deviation, the greater the variation within the data set, and vice versa. Okay? All right, so example 3 says, a farmer is studying the weight of baby chicks after 1 week of growth. I think we have this info on another question. They find the weight in ounces of 20 chicks. The weights are shown. I want to find the mean, the IQR, and the standard deviation for this data. And we want to round to the nearest tenth, include appropriate units, give an interpretation of the standard deviation. All right, so let's pause and enter this whole list into lists and spreadsheets. Let's find the mean, which is X bar, IQR, Q3 minus Q1, and then standard deviation, sigma X. All right, so from the calculator, we have come up with the mean to be 3.7 ounces, right? And the IQR, you should come up with 5 minus 2.5, which is 2.5 ounces. And the standard deviation is 1.7 ounces. And it also asks us, give an interpretation of the standard deviation. So think about what that definition said. Okay? How far a data point is away from the mean. Okay? How far a data point is away from the mean. So we've got the mean is 3.7. Okay? So we can say on average, a typical chick's weight, okay, context of the problem, lies 1.7 ounces away from the mean weight. Away from the mean, which was 3.7. Okay. On average, a typical chick's weight lies 1.7 ounces away from the mean weight, which was 3.7. Okay. So 1.7, kind of a small number, okay, a smaller standard deviation. So when we look at, just kind of eyeball these numbers, there isn't a huge amount of spread in those numbers. Okay? We don't have some, what are these, 1 week old chicks? We don't have a 1 week old chick that's like a pound. Okay? We don't have a 16 ounce chick, all right? Or 12 ounce chick. They're all pretty close between 1 and 6. We do have one little chubby guy right there, 8 ouncer. Okay? All right, so let's go ahead. Let's flip the page. So a marketing company is trying to determine how much diversity there is in the age of people who drink soft drinks. They take a sample of people and ask them which soda they prefer. For the two sodas, the age of the people who prefer them is given. Okay? So we got soda A and soda B, and they ask them their ages. Explain why standard deviation is a better measure of the diversity in age than the mean. What happens with the mean sometimes? Yes. The means could be equal, okay? So we could put down that. We don't know. What else happens with the mean? Okay.
The outlier can bring it either up or down.
Okay, yep. An outlier. Spelled that wrong. An outlier can bring the mean up or down. Okay. So, and it says, if we're talking about the diversity in age, so we're looking at how spread out or not spread out the ages are. The mean doesn't tell you that. Okay, the mean is one number that doesn't tell you about the variation. Right? The standard deviation tells you more about the variation in ages. Which soda appears, so just sort of on looks, appears to have a greater diversity in age of people who prefer it. How did you decide on this? So by appearance, which one of our variations can we go on appearance? Bronze, silver, or gold? Range, IQR, or standard deviation? Jack?
Range.
The range, okay? You can eyeball range pretty easily, okay? So which one appears to have a greater diversity? What do you think? Yeah. Soda A, okay? Soda A appears, okay, to have greater diversity. Okay, and we used range. Okay, the high and the low. So what do we got for the high? Is 44 the oldest?
Yeah.
Okay, and which one's the youngest? 16. Okay, as opposed to soda B's got what? 18, 30. 18. Do we have a 30 in there?
Yeah.
Yep, right next to it. Okay. All right. So now it says, okay, use your calculator to determine the sample standard deviation. Okay. Now, that's a change. Sample standard deviation, when you go to your calculator, it's not going to be sigma x. It's going to be S x. That's the sample standard deviation. And I'll explain the difference. I'm just going to write SD instead of standard deviation. Sigma x is the population standard deviation. Population is everybody. Sample is just a small amount of the population. Okay, you'll find that they'll be close. Population is everyone. Sample is just a sample, a small chunk of the population. Okay? All right. So I put in data set A, and mine came out to be, so Sx is right above sigma x. So to the nearest 10th, data set A is 9.1. Okay, so the standard deviation for A, 9.1. And the standard deviation for B, what'd you guys got? 4.1. And our label, we're talking about ages, so it's years. Okay, so we did that, we rounded. Did your answer reinforce your pick from B, and how? Okay, so in B, just by looking at it, by using range, we said soda A appears to have greater diversity because the range is bigger. Does soda A have the larger standard deviation? Yes. Okay, by using the standard deviation, you see it's 9.1 compared to 4.1. So how this one, okay, greater standard deviation, therefore greater diversity in ages. Okay. All right, and this box in here just reinforces population versus sample, okay, what I talked about. So population is sigma, and sample is S. Okay. Last one, quick one. You don't have to do any calculation on this. It says, which of the following data sets would have a standard deviation, population, closest to 0? Remember, the smaller the standard deviation, the less the variation in the data. The greater the standard deviation, the greater the variation in the data. Which one is going to be closest? Have a standard deviation, not just a number, a standard deviation closest to 0. Kylie. 3. Why 3? Ma'am.
Why did there's two differences between 11 and 13?
There's less variation, so he quick and eyeballed it and looked at the range and said, yeah, there isn't a lot of variation. There isn't a lot of spread between 11 and 13, the high and the low. Definitely looking at choice 1, 2, and 3, way more variation going on in there. Okay, those would have larger scales.